Alrighty, so please welcome Sam, who's going to talk about Serverless-Side Rendering. Yay.
Good. Thank you. Okay, I'm really happy to be here, listening all these different topics about serverless. I'm Sam. I'm a techie at ThoughtWorks, and I'm going to talk today about the potential impacts of serverless in the front end. How many of you work in the front end? Yeah, well, not many. Well, yeah, good. A couple hands. So, today I'll be trying to demonstrate how can we use server-side rendering in serverless to improve the performance of web or single-page applications. So, despite the recommendations and advice from the people that love me and care about me, I'm doing a demo. Hopefully by the end of this, you walk away with maybe new ideas, a new tool in your belt to use in your current project. So let's start. Server-side rendering. Server-side rendering is nothing new. Server-side rendering is the way we've been doing web development for years. So I'm sure that you're familiar with at least one of these frameworks. We want to forget some of those. But the way they work is they need a web server to process requests and return HTML content to the browser. And in this case, JavaScript is used in the browser to enhance the user experience, to enhance interaction. But JavaScript has evolved, and the browsers have evolved. Well, Internet Explorer didn't, but the rest of the browsers evolved. And now that opened the door to new web frameworks based in JavaScript, React, Angular, Vue, and the new sexy Svelte, allow us to build web applications entirely in JavaScript. And all you have to do now is just return a small piece of HTML code with reference to a JavaScript file that contains your entire application. And the entire application runs in the browser, so you don't need servers anymore. You can put this in an S3 bucket or the Azure storage and serve this through a CDN. And you have a highly available, scalable web application. So if you think about this, this is probably the ultimate serverless solution. So why am I talking about server-side rendering again? Well, there are still benefits of doing server-side rendering. The first one is SEO, search engine optimization. So if you want your page to be in the first results from of Google or other search engines, you want to serve HTML static content. The bots, the crawlers, are not very good passing JavaScript. So your SEO score is not very good if you have a single page application. Even though Google claimed that they can do that now, you're better off serving HTML content. And if your traffic actually depends on social media sharing, you are also better off actually rendering in the server. But the other reason you want to do server-side rendering is this. It's annoying, isn't it? This is what your users are going to see when you are trying to fetch data to populate your page with more content. Because when you serve a single-page application, your JavaScript executes, and you need to get data to populate your page with useful content. And even though the single-page applications remove the annoying server refresh of the server-side render applications, now we need to live with a lot of these spinners. So now that we know what are differences between client-side rendering and server-side rendering, if we're doing a new project, what do we do? We do CSR, client-side rendering, or do we do SSR, server-side rendering? What I would say is, ¿por qué no los dos? Why don't we have both? So server-side rendering in the context of single-page applications means that we can run the same code that will run in the browser, we run it in the server, and we return HTML content to the browser. So this is what we know as a universal app. So you make a request to the server runs JavaScript, potentially prefetches some data, and then renders the application and returns the HTML code to the browser. After that, your browser will also execute JavaScript, and your application will behave as any other single page application. There's still a problem here, and that is that we're running JavaScript in the server, probably using Node.js, and not that there is nothing wrong with doing Node.js in a server, but the problem is rendering is a computing consuming operation. So your server can become quickly a bottleneck. So what do we do? Well, that's the reason why we are here. We replace the server with a function using serverless. So what is serverless? I think we already answered that question. So the idea here is we execute that JavaScript code in a function and return HTML, and this makes our server-side rendering scalable. Very easy to implement. We don't need to worry about maintaining or operating servers. So all the great benefits that we know about serverless now apply to server-side rendering. How does this look like in code? Well, this is an example of a small Express app using Node.js, rendering a React application using Apollo for a GraphQL endpoint. And the key parts of this code is basically importing the right libraries from Apollo to build the Apollo client, and a method called render to string with data from a library called React Apollo. We initialize the client, and all we have to do is use the render to string with data function, passing our React application to it, and then we get in the body, we get a string that we can inject in our template to respond HTML. So it is very, very simple. When we start adding complexity to the app, maybe React Router or Redux, this can get a bit complex. But luckily, today we can find tools and frameworks that help us to build server-side render applications as SPAs out of the box. So I'm talking about frameworks like Next.js for React, or Nuxt for Vue, or Sapper for Svelte. So you can quickly build a server-side render application using one of these frameworks. Running this in Lambda or Google Cloud Functions is also very simple. So this is an example of Next.js application running on Lambda. All we have to do is import the page that result from the build from Next, and then using the render method as a response to the Lambda handler. This is an example of the same application in Google Cloud Functions. It's basically requiring the page and responding to the request with the render method. So implementation is simple. So let's go to the demo then. Basically, what we have here is, right. Sorry. Okay. So there you go. Okay. So this is a small application built using React. This application was built using Create React App, which is a popular library to bootstrap React applications. It displays results of soccer from different leagues. It fetches data from a GraphQL endpoint. The GraphQL endpoint resolves the data from a Lambda function, of course, that we have control on, so we can play with it and see different results. This application is client-side rendering, so when you load it, the application fetches the data, shows a spinner while it's fetching the data. We have here the same version of the application built with Next.js, which is server-side rendering. So as you can see, when I refresh the application, I don't have the spinner. I get immediately the application render, so we can actually see how that looks like. Is the entire HTML is returned from the server. And I want to see what are the differences in terms of performance. So I used Lighthouse to compare the performance between the two applications. And what I got is this. So as you can see, in the left side is the client-side rendering, right side is server-side rendering. And the performance is pretty similar, right? It's 98, 99. So they're pretty good scores in SEO, both. So why we bother, right? It's probably the same thing. But if you look into detail the rest of the metrics, you can see a difference between the speed index in the CSR and SSR. The speed index in the CSR shows 3.1 seconds. The other one is like 1.9. So why is this happening and how that works? And then we need to start understanding what is the nature of speed. What is the speed? What's performance in terms of for a web application? And someone before talked about the nature of speed and studied the nature of speed. And Albert Einstein once he said, "The speed of your app is relative." So he obviously he was probably on his way to work. On his commute to work in the morning, maybe trying to check the Hacker News on his phone, and he thought, okay, the speed of this app for an observer on a train in the Frankston line using this crappy Vodafone connection is different than the one for an observer in a broadband connection in a country with real internet like New Zealand. Well, he didn't say that, but Google said it. Google came up with the concept of user-centric performance metrics, defining speed as an experience. The speed is not a single point in time. It's not just simply a number. It's an entire experience for the user. And there are critical points in time that define the perception of speed of an app for the user. The first one is the first paint, or first contentful paint, and that is when the app displays something. So the user knows that something's happening. And then the next point is the first meaningful paint. And the first meaningful paint is when the user actually gets the information he's looking for. And this is probably the most important point in time, because it's the one that reduces the anxiety in the user. So what we're trying to do with server-side rendering is reducing the time for first meaningful paint, creating the perception of speed. And then finally, the last one is time to interactive, and that is when the browser executes, it's able to execute JavaScript. So how does this look like in a sequence diagram here is for client-side rendering, when you request the app, you go to probably a CDN, get HTML code, and show an empty screen, maybe with a background or something. Then you fetch your first bundle and execute JavaScript, the browser. You get your first paint. Then you get more bundles and execute more JavaScript. Go and fetch the data from an API, and that's why you get the spinners. And finally, you get results and having the first meaningful paint. What happens in server-side rendering is you call the app, the browser goes to a server to get the response. That function executes the JavaScript, prefetches data, renders the application, and immediately returns HTML. So you have at the first response, first meaningful paint. So the time for first meaningful paint is faster in SSR. And then after that, you go and fetch all your bundles, and your page becomes interactive. So I wanted to visualize that, how that works. So what I did is I put good. Not good. So I put these applications side to side. And I wanted to see what is the actual visual difference between the two. So the one on the left is server-side rendering, serverless-side rendering, so it is actually executed in a Lambda function. The one on the right is a classic SPA running in the browser. And what happens when we refresh is this. So it looks pretty similar, right? That's the performance that we were looking at. But what happens if I'm actually on the train or on a poor connection? So you can see the server-side rendering application showing me information a bit faster. And the effect is even better if the network is slower, which is very, very likely. Right? So far, we proved that with server-side rendering, we can somehow reduce the level of anxiety in the users, creating the perception of speed. However, we still have a small problem, and that is what happens if something happens in our server, if our database is slow, and what is the effect in our application. So this is the Lambda function that controls the response here. It's a very simple Lambda function with some hard-coded results. So I'm able to control the delay. So let's say it takes 6 seconds to respond, and see what is the effect that causes in our application. And in this case, this is what we got. We got a spinner in the SPA and a white screen in the SSR, and that is still annoying, right? You still want to tell the user that something's happening, and maybe this white screen is not great. So server-side rendering in that case has a problem. So how do we solve this problem? Again, serverless to the rescue. We are returning static websites now. So we're rendering in the server, and we're returning just HTML. So technically, we can cache that response. So the user goes to a CDN, and it will immediately get the response from or the cache response from the CDN. But we can get a bit smart with that, and we can use serverless to pre-render our application and put it in a CDN before the users hit the CDN. So the application is always available for them, and this is known as serverless pre-rendering. So what we're going to do here is our users get to the CDN, request for the page. The CDN is always going to return HTML, and they're going to return even if it's the version stale. If we have a dynamic page that the content changes very often, we will always return whatever version is in the CDN. And what happens in the background is we can use events to trigger lambdas. So what is an event? That was Danilo's definition. Something happened. We can use a request to trigger a lambda that will, in the background, pre-render our application and put the pre-render version in the CDN. So the next user will get a validated and refreshed version of the application. So the user is never hitting the back end, always getting the information from the CDN, and that will cause the effect on the speed is going to be very, very noticeable. So you can achieve this using CloudFront and Lambda at Edge in a very simple manner, but I'm very, very lazy. So what I did is I used a platform that already does that, and that is Side. They call it the Smart CDN, and all you have to do is one line of code in your backend, putting a cache control header, stale while revalidate, and they will implement all this serverless pre-rendering for you out of the box. So let's see how that looks like. This is the demo. So if you want to go and jump into the page and see in your own devices. So this is the same page now using serverless pre-rendering. So if you remember, okay, so this is the page with the traditional server-side rendering. So it's taking 6 seconds to load. This is the version with serverless pre-rendering. And what happens, this is a caveat, what happens if our content changes? So I have another set of results here to showcase that. And this is the caveat. When you refresh, you get the stale version of the app. Well, the content already changed, but the next user is going to get updated results immediately. So when you do serverless pre-rendering, you always get HTML making your app look faster. So, okay. Good. So I made a small video of comparing the three approaches, just in case the internet didn't work. This is what we can achieve using serverless to improve the performance of your app. So to summarize, speed is an experience. Speed is not just a number, it's what your users perceive as fast. So you can use serverless to get information ready for your users and optimize the information that you present, making your apps look faster. Also, remember that the web is still HTML. And this kind of technique works fine when you are maintaining a blog, or is a newspaper, or is an e-commerce solution. The web is still a HTML, and if you provide HTML back to your users, you get better SEO, you get better performance, and all those benefits from server-side rendering. And finally, well, serverless and front-end. Serverless can help in the front-end. It's not just a back-end technology. You can use different tricks like this to improve the performance of your applications. And that's all I got. Thank you very much.
Thank you, Sam.